Greetings and welcome to the series of lectures on systems of equations, 4.6 Cramer's Rule. So Cramer's Rule is an incredibly useful tool that we can solve linear equations. I'm going to talk about linear equations in two variables as well as three variables with Cramer's Rule. But let's start off a little bit with like a baby step with two variables. So here's Cramer's Rule. The solution set to the system of a1x plus b1y equals c1 and a2x plus b2y equals c2. Well, it's been given by x will equal dx over d, y equals dy over d, where d does not equal 0, right? We never want to divide by 0 in our class, so d does not equal 0. But what does this dx and dy and d mean? Well, they're the determinant of a very particular set of values out of our two-variable system of equations. So d is going to be a1, a2, b1, b2. dx is going to be c1, c2, b1, b2. And dy is going to be a1, a2, c1, c2. If you want to try and memorize it, d is remove the answers, and it's going to be the coefficients of x and y. For dx, remove x, and therefore it's the coefficients of y and the answers, and the constants. And dy is remove the y's, and it's going to be the coefficient of the x's and the constants. All right, let's use Cramer's rule to solve the system 2x minus 3y plus, equals 4, 4x plus 5y equals 3. First we need to calculate d, which is cover up the constants, and it's going to be the coefficients of the variables. 2, 4, negative 3, 5. Right? Our determinant is going to be 2 times 5 minus 4 times negative 3. Okay. 2 times 5 is 10. 4 times negative 3 is 12, but subtract, or is negative 12, but subtract negative 12, therefore it's a plus 12, therefore 22. Okay. Let's calculate dx. Cover up the x's, and it's the coefficients of the y's and the constants. So negative 3, 5, 4, 3. Okay, but 4, 3 first. 4, 3, negative 3, 5. Order matters here. Right? 4 times 5 minus 3 times negative 3. 4 times 5 is 20. 3 times negative 3 is negative 9, but minus a negative 9 is positive 9. 20 plus 9 is 29. dy, cover up the y's, and it's going to be the coefficient of the x's and the constant. So 2, 4, 4, 3. 2 times 3 minus 4 times 4. 2 times 3 is 6, minus 4 times 4 is 16, therefore negative 10. Okay. Now that we've figured out all the determinants, we're going to solve for x and solve for y. Remember, x will equal dx over d, and y will equal dy over d. Right? dx was 29. d is 22. dy is negative 10. And d is 22, and the only thing that I can do here is I can reduce the negative 10 over 22 to negative 5 over 11. So my solution set is 22, 29, oops, sorry about that, 29 22nds and negative 5 11ths. And we have 3 or 4 other methods for solving this system. Try it out. See if it works out to 29 22nds and negative 5 11ths. I bet you it does. Cramer does not lie. very similar to the system of equation in 2 variables as the 3 variables. So still the answer is going to be x will equal dx over d, y will be dy over d, but now with the third variable it's going to be dz over d. D is going to be all the coefficients of the variables. So a1, a2, a3, b1, b2, b3, and c1, c2, c3. dx is going to be the constants without all the x's, but with all the coefficients of the y and z. dy is going to be the constants and then all the x's and all the z's. dz is going to be the constants with all the x's, coefficients of the x's and the y's. Okay. It looks complicated, but it's not. It's not really complicated. It's kind of stick your finger over it, cross it out, and see what you have left. All right, so d is get rid of all of the constants. dx is get rid of all the x's, but write the constants first. dy is get rid of all the y's, but write the constants first. dz is get rid of all the z's and write the constants first. Okay, setup, not difficult. Or at least try to not think of it as difficult. Just follow that, cover it up, and then, all right, I have a system of equation in 3 variables. I'm going to use Cramer's rule. And I'm going to figure out d, dx, dy, and dz. Hopefully I gave myself enough room here. All right, d, cover up all the constants and just grab all the coefficients of the variables. 1, 2, 1. 1, negative 1, 2. 1, 1, negative 3. I'm not going to figure it out yet. I'm just going to write them down. Okay. dx. Okay. Cover up the x's. Write the constants first. 6, 3, negative 4, and then it's going to be all the y's. 1, negative 1, 2, 1, 1, 3. So all the y's, all the z's. dy is going to write down the constants first, and then cover up the y's and write all the x's and all the z's. Lastly, dz, write all the constants, cover up the z's, but write down all the x's, all the coefficients of the x's, and all the coefficients of the y's. Okay. Now I have to figure out the numeric value of this, but that's just multiplying and adding and subtracting, so it's not that bad. I just have to remember exactly. I'm going to use the first row for all of them, so I do know my sign array is going to be plus, minus, plus, plus, minus, plus, plus, minus, plus, right? Okay, so first value is 1, and its determinant is going to be, and I'm just going to do it in my head, negative 1 times negative 3 is 3, minus 2 times 1 is 2, minus second value is 1. That leaves 2 times negative 3 is negative 6, minus 1 times 1 is 1, plus 1 times 2 times 2 is 4, minus 1 times negative 1 is positive 1. Okay. So far so good, I hope. All right, 1 times 1 minus 1 times negative 7 plus 1 times 5. Okay. It's going to be 1, negative 1 times negative 7 is positive 7, plus 1 times 5 is 5. So 1 plus 7 is 8, plus 5 is 13. D will equal 13. Now let's do the same thing for dx. 6 times negative 1 times negative 3 is 3, minus 2 times 1 is 2, minus, second element, 1 times 3 times negative 3 is negative 9, minus negative 4 times 1 is negative 4, but a minus negative is a plus 4. All right. Third element, 1 times 3 times 2 is 6, minus negative 4 times negative 1 is positive 4, but minus positive 4. Okay. 6, 3 minus 2 is 1, minus 1 times negative 5 times negative 9 plus 4 is negative 5, plus 1 times 6 minus 4 is 2. That's going to be 6. Negative 1 times negative 5 is plus 5. 1 times 2 is plus 2. That leaves 13. It's okay that I got the same value, right? All right. 6 times 2 times negative 3 is negative 6. Minus 1 times 1 is minus 1. Minus, second element, 1. 3 times negative 3 is negative 9, minus negative 4 times 1 is negative 4, but a minus negative 4 is a plus 4. Okay. Plus 1 times 3 times 1 is 3, minus negative 4 times 2 is negative 8, but I already had a negative there, so plus 8. Negative 6 minus 1 is negative 7. Negative 9 plus 4 is negative 5. And 3 plus 8 is 11. Right. Negative 42 plus 5 plus 11. And let's see, negative 42, but plus an 11 is plus a negative 31, but plus 5 is a negative 26. Looking good so far. All right, one more to do. I know it's a little long and lengthy, and it's a little on the tedious side, but the math is not the hard part. It's just putting all the pieces in place. All right, 6 times 2 times 2 is 4, minus 1 times negative 1 is negative 1, but I already had a negative there, so plus 1, minus 1 times. Okay, cover up that row. 3 times 2 is 6. 4 times negative 1, or negative 4 times negative 1 is positive 4, plus 1. 3 times 1 is 3. Negative 4 times 2 is negative 8, but it would have been a minus negative 8, so that's plus 8. All right, 6 plus times 5 minus 1 times 2 plus 1 times 11. That is 30 minus 2 plus 11. 30 plus 11 is 41, minus 2 is 39. Okay. Seems like a lot of work, but here's our solution set. X equals dx 13 over d 13. X equals 1. Okay. Y equals dy is negative 26 over d, which is 13. Y equals negative 2. Z equals dz, 39, over d, which is 13. Z equals 3. Our solution, 1, negative 2, 3. Kind of cool that just with kind of and I say simple in the sense of we're only multiplying, adding, and subtracting. With using those 3 plus a little division at the end, with those 4 operations, we solved a complex system. This is a pretty complex system to solve with just adding, subtracting, multiplying, and dividing. I think it's kind of cool. So that's it for this lecture. Until next time, be seeing you. Oh, but before I go, one more thing. Sometimes your system doesn't look quite complete. So I just want to write down what d dx and dy would be here. So d dx dy and dz. I'll let you solve it on your own. Okay. So here's I have a system. X plus y equals -1, 2x minus z equals 3, y plus 2z equals -1. I can rewrite this system as x plus y plus 0 z's equal -1, 2x plus 0y minus z equals 3, and 0x plus y plus 2z equals -1, right? So here's D. Again, cover up the last column. 1, 2, 0. Y's are 1, 0, 1. And Z's are 0, negative Z. Ooh, negative Z is not negative Z. It's -1 and 2. Dx is going to be -1, 3, -1. Then the y's, 1, 0, 1, 0, -1, 2, and the z's. dy is going to be -1, 3, -1. The x's, 1, 2, 0, and the z's, 0, -1, 2. And dz is going to be the constants, the x's, and the y's. Okay. From there, you're going to use the same method of finding an element using its minor, finding the determinant of the minor, and going through using your system, if that's the system you want to use, or the method that you want to use, or you can use the diagonal method. But I wanted to make sure that in the event that you ran into a system that seemed to be lacking some information, that you can fill in the blanks with zeros. Literally fill in the blanks with zeros. All right, that's it for this video. Until next time, be seeing you.